done with most of the number theory questions, you can now solve the examples from the Pearson or the Vedantu book which you have. Okay, so now let's start with functional equations. Okay, so a functional equation is an equation where the unknown is a function. It's like fx equals x. Okay, so the x is the function of fx, not just a number. Okay, instead of solving for x, you solve for the form of f of x. Okay, now for an example, f of x plus y equals f of x plus f of y. Now this asks what kind of function satisfies the property of all real numbers x comma y. Now we can check the trivial solution, which is f of x equals 0. Now f of x equals 0 will uh, satisfy the function because it just satisfies. But now can you think about the actual solution for this? So we have an actual solution for this. Let's move on to the solution now. Okay. So equation involving f of x, not just x. You have to mind that and you have to keep it in your mind. Okay. So now in our example, f of x equals 0. This is a trivial solution and it works. Now f of x equals kx is a linear equation. Okay. Now if we put that into it, this is satisfied. Okay. Because I'll show you that. Just a second. Okay. So now I've just written the solution here. So if f of x plus y equals k into x plus y equals kx plus ky equals fx plus fy. Alright, so this satisfies our function. Now you can solve the below examples. Alright, this is not minus, this is just an indicator. Okay, now let's move on to the next part, which is the main part actually, so, which is Vieta's relations, which you might study under the 10th grade polynomials chapter. Alright, so Vieta's relations are given as, wait just a second if this looks confusing. Yeah, so if ax square plus bx plus c equals 0, it and has the roots alpha and beta. Alpha plus beta would be minus b by a, and alpha beta would be c by a. Okay, bad, excuse me. This is useful for symmetrical sums and root manipulations. Okay, so some symmetric functions of roots are like, if we want to find alpha square plus beta square, we want to just square this thing as a whole. So alpha plus beta whole squared minus 2 alpha beta would give us our desired result. Now you can try some of the other sums and examples. Okay, this is one of the ones which we just solved. Now let's go on to the next part. Now in cubic, if we have three roots alpha, beta and gamma, now the sum of the roots would be minus b by a again. This can be proven using geometrical method and also one of the methods using the quadratic and the cubic formula. Okay, now there are many proofs of this. We will discuss one of the proofs. Okay, now these are two questions I would like you to try, because these are some questions which involve using the inequality and also using the concept of Vieta's relations, and also you can use the concept of discriminants if you know that, which is basically just that wait just a second, right here. Okay, so to write here, discriminant is shown by the triangle symbol or capital D, which is equal to b square minus 4ac. Okay, Now, there are a few conditions which you have to follow in order to have uh, certain certain kinds of solutions. Now, if d is greater than 0, the roots are positive always. If d is less than 0, the roots are negative always. And just a second, I guess I've messed up a bit. Sorry for my mistake. These are not positive, sorry. They can be negative. The roots are real. Okay. And here they are imaginary. Basically iota, which is represented by the number I, which is the square root of -1. Okay. And if d is equal to 0, the roots are real and equal to one another. Alright, now you can use this concept in here. These two questions. Now, I just want you to try these questions and try it on your own. Try it with the inequality concept, the discriminant concept, and now let's go on to the proof of our first proof of our this alpha plus beta plus gamma proof. I'll just prove the second one, these two. Okay. Okay. So now proving this, we can do a certain approach. Now, one proof which I have in my mind, which I discovered randomly, and I did it on my own. Okay. And you should basically try to prove things rather than solve questions first. Okay. Because proving things automatically gets that into your mind. So now, let's say I'll take I'll take z and y as the roots of ax square plus bx plus c equal to 0. Okay. I'll just take a fresh page. Just a second. Which one is this? Just so, my bad. Now we can replace the value of x as in like a into x minus z plus b into okay. Now we can like this is the LHS, this is the RHS, this is the RHS. Now what we will do is we can see a quadratic can be formed here as well. So now the quadratic will be ax a into x squared x squared minus what will it be? X squared minus zx minus y x squared minus yx, and then we will have minus zx minus y yz plus yz. Now this is equal to the RHS. Alright. Okay, so now I expanded this into the original a new quadratic, and then I simplified it into ax square minus a into y plus z x plus a into yz. This is again equal to our original quadratic, which is ax square plus bx plus c. Now if we compare the coefficients, let's compare x square. It matches a. Here also a. Coefficient of x, which is minus a into y plus z equals b. Okay. Constant term is a into yz, which is equal to c. Now we can find out, we can add y plus z to get minus b by a, and yz to get c by a. That's all. This was the proof of the Vieta's relations. There are multiple proofs, but this is one of the proofs I got. And you can try to solve the Pearson book now. You can still wait for more lectures because I will cover more parts of algebra, because algebra is very important now. If you have done ratio and proportion and all the basics of algebra, you can complete those exercises, and I assume you must have completed it by now, and you can do it on your own. There are just a few simple formulas and things you have to mug up for those simple questions, and then you can move on, gradually move on to these questions, and that's all. Thank you so much for today's lecture. So, bye.